How many slides do you have, Gabri?
How many?
How many slides? How many slides in presentation you have? A lot?
I have 31.
31. A lot of things that we talk on.
There is a lot of stuff.
Yeah,
inside.
a lot of stuff to show.
Yeah.
You know, now it's been a lot that we have released the MAM, our IoT module, and we are integrating many things, right?
Yeah, we are releasing also a lot of documentation, so we have to discuss it to guide all the people who are going to implement this new model in their design.
Yeah, we are still a couple of minutes to wait, and then we'll start, so we can show you a couple of things. But in the meanwhile, I'll talk 1 second about the company to the people that are here, so they understand better what we do and how we do that. And basically, Move is a company that holds 2 different business units. One is called the Move Solutions. The other one is called MAMWLExx, which basically are 2 independent business of units. They do different things. Move Solution is about structural health monitoring devices. So we design structural health monitoring product for the structural market, while instead the MAMWLExx, we design IoT module to speed up, for example, a design of a new product into the market, and it's a different business unit, but of course the MAMWLExx power up our sensors as well of the Move Solutions. So they're quite separate, independent, but let's say we do a lot of research and development in MAMWLExx, which we bring it out also in our product for the Move Solutions. And that's a little bit where I think we have started with, and we'll speaking about in a couple of minutes about that. But yeah, the Move Solutions actually, the Move Solutions and it's power from the MAMWLExx division actually. So that's why. Okay, so we will start in about 1 minute. So I'll start to introduce Gabriele. Right. Gabriele is the one of the partners of Move and the chief technical officer. So he's in charge of, let's say, be sure that every product that we do, every stuff that we release is compliant, if it's fully working, and he leads a team of R&D engineer which develop new things, and is one of the mind behind every piece of products that we release in the market. Ciao Gabri.
Ciao Ferdi.
And me and Gabriele, we have met in a university. We were studying electronic engineering together. He was better than me, a lot better. And yeah, we started about 4 years ago, and it's been a long journey. Okay, and then me, I am one of the founder and the managing director of the company. I run all the operation, Move Solution and MAMWLExx, and it's an exciting period. It's an exciting moment for us. We're growing so fast, and it's thanks to Gabriele and the other team's member, which they brought a lot of our innovative technology into every piece of product. Okay, so what we're going to do today is we're going to analyze and speak about MAMWLExx division. I'm going to show you a little bit what is the concept behind the MAMWLExx division and why we have done it. And Gabriele will take, let's say, most of this webinar to tell you how to create an IoT device, which is extremely important. Basically, we do love LoRaWAN. We love the LoRa modulation, and we have passed many years to design products that have enough power, that have the features, really, that have really interesting features. And sometimes it's hard to design everything on LoRaWAN, or to pick a module from a distributor and start to design it. And we wanted, what we thought a couple of years ago is we wanted to being able to give to the designer and to the company as well a fast experience on designing a product. And especially we wanted to let's say give a product that have already some solution on top, without the designer to go through all the problems that an IoT product have and solve it. I'm talking about RF design, which is really really complex in a certain way. You need to respect some norms about regulation on radios and other things, and it sometimes get really complicated. So we have started to say why we don't bring what we have learned into the market, and some of the problems were we have learned from our product as well, and we have solved it. And we said why we don't bring it a product in the market which solve some solution of the problems that we have found. Okay, so that's where we started. And I'll tell you what, there are a huge amount of IoT modules in the market, right? There are an enormous number, but the question is, and there was the thing that we had, let's say, we have decided to build this business unit is, are the feature of this module power enough for your application? When we started a couple of years ago, we had a couple of modules out, and we started to create the product around. At the end, we got a huge bottleneck. We wanted to release products with another, for example, other features, but the module that we were using, it wasn't power enough. And that creates a huge enormous number of problems, which we at the beginning with I think Gabriele, when we've spoken together, we were saying why we don't, let's say, postpone it, right? Why we cannot do that? We need to still use the same module, because we're not going to have a fast time to market, right?
Exactly.
And
yeah, there was of course the problem that changing the design would have come with a lot of other problems, implementations, and so we had to stick to the same design to reach the same reliability. That's because we didn't have any simple model that we could have implement in our design, and that's the reason why we choose to design it
right
by ourselves.
Right. And basically I'm going to list a couple of problems that we have found. For example, a huge problem, I think, for my side, I don't know you, Gabby, but a huge problem is you want to design a product, okay? And then you find out, you see a data sheet. You go through your data sheet and you say, look, these things have 30 pins. And then you find out that most of the pins are ground. Most of the pins are, I don't know, GPIO, which you can actually access because they are made for debugging for the manufacturer itself. So even not for debugging for your product, but it's made for debugging for the manufacturer when they build it. So it says, so you think you have enough, let's say GPIO around your model, but at the end you find that you have I don't know, a couple of one. And it gets messy at that point, because basically you says, okay, I think I can put, let me see how can I route things, this peripheral, this other and you find out that you can't. And that is a problem, right?
Yeah, for experience, you pass more time to do like a puzzle work to implement different peripherals with different serial communications, and that time would not be wasted if you have a lot of purposes. Of course, if you have a lot of GPIOs, so you don't have to choose what serial communication to use, because you have everything inside this. So it's a paradox, but at the end it's more simple.
Yeah, one time we found that we picked a model which we could use the I2C but not the SPI together because of the power concept. So huge mess, right? Huge mess. The other problem is with the RF design. So when you work with LoRa, the RF design needs to be really, really good. You need to be really well to do the RF design, because you have double band. For example, let's say Europe is on 868, and then you go on USA, which is 915. So you need to be able to cross both bands in a certain way. So, if you go and check, you need to check it really well, a scattering matrix. So you need to know what you're talking about, right? You want to have, for example, plus 22 dBm. So you need to be really accurate on the oscillator when you launch a signal at that power. You need to be really careful with that. So there are a lot of things that wasn't really working for us, for example, and that was another problem. Another problem, it was probably one of the biggest that made us change and decide to create our product, our module, is that we weren't able to have features, for example, firmware update over the air, time synchronization, or other, let's say, high important, powerful features that we couldn't have it, because the MCU inside the module was so he had a lot of power, let's say, right? And the one of the solution, the only solution could have been to change to bring it inside another MCU. That just complicated the things around. So we were at a point that we said, why we don't make this? And we made it. And we created the MAMWLExx, which has a longer name, but what is basically a low power radio module with an M4/M0 plus. I will explain later what this means, core. And is a low power radio module. It's really extremely small as a module, and it's designed to bring all the power of a chip. We especially use the STM32WL chipset from ST, and it's designed to bring all the power of that chip on a system on module, which is easy to integrate, which is easy to work with. Okay. The number of GPIO is really important here. We brought up a huge number of pins out, but at the same times we said with Gabi, okay, we want to bring everything out, but at the same times we said we want to make it easy, and that's where the design came through. We have placed 66 pins, but from 53 to 66 is just ground, and they help to align, to self-align the modules during manufacture when you do a solder reflow or other things. So it's made to do that, and on each of the part there is a huge number of GPIO with different kind of let's say operation pins that you can find, from digital to ADC. We bring out about 12 pins with ADC, one DAC. We have DMA support for I2C, SPI, UART. We have a huge amount of I2C and SPI that you can see on the data sheets as well. So a huge amount. Then we said, okay, we wanted to have power inside. We wanted to have power, okay? And we have designed we have picked a version of the chip which is 128, but we're going to release the 256 kilobytes version, so both of it. And it has inside the 32 bits ARM M4, and we basically the chip is made to host also an M0 Plus, but we don't use that version. I think the M0 Plus is only used for radio purpose, so you are not able to access to the M0 Plus. But the M4 gives you a huge number of DSP instruction set that you can use, for example. So it's a really interesting power features that he have. The clock speed can go up to 48 megahertz. That is really interesting clock speed. And it gives you all the low power state where you can go, for example. Talking about the modulation, okay, we didn't want to give you the pain to create a let's say RF design on top. So we have designed it for you, and we have put a coaxial cable. We have placed a coaxial cable on the top, so you don't need to do anything else than just plug an antenna, and that's it. The module is double band, which you can program it. It gets up to plus 22 dBm. Inside there is routes for 2 TX power pathway and the one for the receiver, but you see it just you don't need to do anything because it's just on the antenna on the coaxial table, so it's a route with some DC-DC switch inside. And of course, you are able to use the modulation that the radio chip gives you. So from LoRa, GFSK, MPSK, BPSK, and whatever. Now, if you compare it with other popular model in the market, you'll find that our era is the one that basically minimize, let's say, the size, but at the same time, have the most number of the highest number of GPIO in the model itself, and you can see it. You can see it here, just as a comparison that basically our area is so small, and but we bring out numbers, a huge amount of GPIO out with T6O, with everything already inside, and you don't need to do anything else. Same things to compare with other module. You can see that you can go lower, but you will have a lower amount of GPIO. And then if you go upper, you probably come out with a double size in the area, which affect a lot of the design on the PCB as well. So we have created to design a nice, let's say, number, nice ratio between size and GPIO. That's the thing. Also, we target markets as edge computing application, where you need to work on the edge algorithms. We know well our friends of Edge Impulse. You can basically use Edge Impulse and bring a machine learning code on our module as well. Or we're targeting application from the simplest one to the most complex, from smart metering to a complex sensing application. And so this gives you all whatever you want to do, and wherever you let's say your fantasy as a designer wants to do on your application with one module. That's the real target of this. And then now I'll leave you the words to Gabri, but just to conclude my part on the support, we have a team of people that will help you, the design, will help you to try to find the correct way to use our product. So you're not left alone. We will release also in the market a DVK, new DVK, which is called the Dante one, which is compatible with the Raspberry Pico. Edge Impulse ready, that means that we already made some software that run on the Edge Impulse, for example, and it's fast enough to prototype. Okay, and the idea is to combine machine learning and LoRaWAN on top of that. Okay, you can there are really nice network server, LoRa network server that, for example, the Think Industries, the Think Network, LoRa IoT, which you can speed up the process on creating a LoRa application. Okay, but then I won't say anything else, and I will leave the words to Gabri, which will show you everything else in the module itself.
Yeah, I'll share my screen. You can see that.
I will add one thing, that there is a question. Is a QFN or BGA? I think it's related with the question regarding the chip that we use, right? Is a BGA, or more correctly, UFBGA, right? Right, Gabri?
Yeah, it's quite LCC. It's an LCC package.
The modules. I mean, I think the question was about the chipset, I think.
The chipset is the BGA.
Right.
Yeah, it's the BGA because it's the most compact, and of course we needed to shrink all the components to stay in that size. So yeah, it's the BGA.
All right.
Can you see my screen?
Yes, perfectly.
Perfect. Okay, so yeah, as Ferdinando said, I'm Gabriele Corsi, and I'm the CTO, so I'm the most technical figure here. So I will show you what are the tips and guidelines you should follow to instantiate your the MAMWLExx model in your custom design. So let's move on. I wanted to start by a simple question, which is, of course, an introductive argument, but the question is, why should you implement LoRaWAN communication in your IoT device? That's the question which is at the basis of a new design on LoRaWAN. That's why LoRaWAN is a low power wide area network, And what does it mean? The the name contains all the things that you have to know. It's a low power network, so it allows you to consume very low current. So the batteries will last a lot, years and years, but it is able to cover wide areas. So it is perfect for rural environments, like, for example, harvest or something related to agricultural sectors, but it's also very good in urban situations because the band that it uses, it presents a high penetration in buildings, so you can cover wide areas even with only one gateway. And that's the reason why companies like, for example, TTN, the Things Network, is covering a lot of cities with a bunch of gateways to give free access to the LoRaWAN network to everyone who wants to connect some sensor to the cloud. So that's the key point. So as I said, LoRaWAN presents very high advantages. Another one is that it is a very low cost solution. If you go, for example, for the narrowband IoT or LTE Cat M1, you will go for higher cost, which comes from the chip. So for the chip itself, which costs a lot, and comes even for by the contracts that you have to have with cellular networks, which are not cheap at all. So another things that is very good is the independence from cellular operators. So if you don't have the coverage, so if you don't have the coverage on a specific area, you can establish fully independent LoRaWAN network by yourself, deploying a gateway and connecting to the cloud. So you have complete freedom on every aspect using this protocol. Of course, there is also the security aspect, which is very important. All the communications that rely on LoRaWAN are encrypted with a very strong encryption method. So no one can access the data that you are sending over LoRaWAN. And that is an important aspect, of course. So basing on these advantages, what are the applications? Of course, smart meters, because as I said, with only one gateway, you are able to cover wide areas, also in urban environments. Supply chain and logistics, also this, LoRaWAN is going through a very high development regarding the asset tracking and everything that relies on that. In Semtech, which is the owner of the LoRaWAN protocol, is pushing a lot on asset tracking. Also with technologies which are independent from GPS, which is a higher cost. So it is becoming a protocol which is gaining a lot of importance in a lot of aspects. And the other one, of course, agricultural sensors and so on. So that's a very interesting protocol which has a lot of implication and implementation in the future, of course. So that's the next question. So what do you need to deploy LoRaWAN communication? You need, as I know, someone who makes it easy. That is not, you know, an easy thing. That it's not an easy thing at all, because we faced a lot of problems in the last year, as Ferdinando can confirm, when we tried to implement LoRaWAN communication in our first project and sensors, because LoRaWAN, even also because that was the first years of LoRaWAN spreading, so there wasn't so many documentations, but there wasn't models which were able to ease all the process of implementation of this technology. So one way would be going from the A to Z, implementing your own solution, starting from the microcontroller, going through the Semtech and LoRa transceiver with all the RF matching, with all the passives, crystals, RF switch, and so on. So you would have a very complex design, which are you know, possible only for people who are who have a strong experience in RF design and architectures. Or you can go simply with this model. So this model integrates everything in a very small footprint. You can see it by this picture. So that is the model that you could use to ease all the implementation process, right? So let's see what are the features that makes a model perfect in some way. As you can see, the architecture of the model, it's in this picture. So there is the brand new STM32WL, which is the microcontroller which integrates Cortex M4 and an M0 Plus, which are both accessible by software and firmware. So you can choose how to use them independently. If you want the Cortex M4 to use the radio, you can. If you want the Cortex M0 to use it, you can either. So it is all integrated in one single chip. It comes with a great computational power. So that was one of the key aspects that pushed us to design a new model. We needed a high computational power, which wasn't able to, which wasn't on the Cortex M0 Plus, which is done for very low power applications. So that's the key aspect of this model. Another thing is the high stability that you want with a model. In this model, there is the we decided to go for an integrated TCXO, which is a temperature compensated oscillator. That is very important when you want to deploy this model on a sensor or on a custom PCB that has to work in really harsh environments. So high temperatures, high humidity, or everything you want, because you want to have high stability in every condition. And that's very important also for the sensitivity of the radio, because of course deviation on the frequency of the radio will lead to lower sensitivity, and the extremely high sensitivity is one of the key aspects of LoRaWAN, so you want to miss it. Another thing is the low power consumption. We decided to integrate inside the model the DC-DC converter to make it the most efficient as possible. So we had two choices, but we wanted to integrate all the components that you need inside the model. So every switching components regarding the DC-DC converter are just inside the model, and you don't have to implement them outside. So there is everything inside. Another key aspect, of course, is the compatibility. As Ferdinando said, you have the compatibility for LoRa, GFSK, GMS-SPK, and so on. So you literally can do anything with this model. The other key aspect that we wanted to this model to have is the capability of going through high and low power. So we maintain the two TX, the two transmission paths that comes with the STM32WL inside this model. So, of course, if you are in Europe and in most countries, you can't use the high power the high power transmission path, of course, because you would go against the regulations. But in countries like US and Australia, that you can where you can transmit up to 30 dBm, you will find very useful to this feature, because it allows you to transmit at higher powers if you have to cover even wider environment. So it is a very nice feature. Another key aspect that is a key fact is the worldwide frequency plan on a same model. That is not an easy thing, because with one model you grab also the compatibility, the worldwide compatibility. So that means that you don't have to have a different assembly line for every different country where your sensor will be deployed, but you can maintain only one assembly line, so only one component to handle for a worldwide compatibility. You will only choose by software, so the band to where the model has to operate by software. So that is a freedom which is very important, especially if you are a worldwide company, of course. And doing that, we maintain perfect RF matching parameters, even with a wide bandwidth. Why the others, often doesn't offer this capability? Because it is a bit complicated to implement a wide bandwidth RF matching. So perfect transmission parameters on a wide bandwidth. That is because it's very complicated in a very shrink design. I don't want to go in details, but you need more components to widen the bandwidth of a model, and we was able to do it even in a very small design. So it's a very great thing, we think. The model comes with two variants. One is the 0 and the other is the 1. So these are two variants which are different for the antenna output. The 00 version goes with the micro FL connector, so the coaxial connector. That is the easiest way to implement a design, because you don't have to handle any RF component, because it is everything inside the model. You just only have to attach your antenna with a micro FL connector or a micro FL pigtail, and you are on, just like that. If you want to implement a different solution, for example, if you want to go for a chip antenna or PCB antenna, which could come very, very important if you are in a very small, compact design, you can go and get the pad antenna version, which is the 01 variant. So in that way, you will route the RF pad outside of the model with your RF matching circuit. So you have the complete freedom of for it. So that's another versatile thing that we offer with it. As I said, all of this comes with a very, very small footprint. So it's not, as I said before, it's not an easy thing, because we integrated so many things inside the model, having the GPIOs unaltered and having the dimension very, very low. If you have to do a design which is really, really integrated, which have to have very, very small dimensions, with this model you can do it without having to have compromises. That's the key point. As I said, everything comes with high GPIOs count and a bunch of serial communications that comes with it. So you have 36 effective GPIOs. You have E2Cs, you have SPIs, you have UART, you have timers, of course, you have ADC, DOCs, you have everything. You have just everything. So you have the complete freedom of choosing several different peripherals, because you have the resources to handle them. That's a very, very great thing. Another thing that a model could have is the certainty, which is I think that if you are a hobbyist, probably you don't mind a lot about it, because of course the prototype has to work, but it doesn't have to be certified, or it doesn't have to go in mass production. But if you are a company which have to deploy a lot of sensors worldwide, you have to get the you have to be sure that your design will work and will pass the certifications, preferably at the first attempt, of course. So with this model, as you can see by this slide, we passed all the certifications in a great way. So all the radiated emissions are far behind the limits. Of course, the 86.7 megahertz tone is above the limit, but that's the tone that we radiated during the transmission. So that's not the that was not counted on the certification, of course. So our model comes CE certified with all the radio standards that are here in Europe. we are also going through FCC certifications, of course. So soon we will get it as well. And that's so why I talked about certainty. Why using this model you are 99% sure that you will pass the certification, of course, regarding the RF aspect of your board, because everything is integrated inside the model. Every component is just placed and routed in the way that it will not have any problem regarding EMI and EMC. So signal integrity problems or something like that, you will not face anything regarding that. It's all integrated inside the model. Especially if you choose the microFL connector variant, everything that is radio frequency is contained inside the model, and you literally can do anything outside the model, because RF will not lead you to any problem, of course. Another thing that even in, especially in this period, it's a very, very huge problem. It's the component supply chain. There are a lot of problems, as you can see, on the supply chain. So grabbing components, it's quite impossible in these times. So you will have a lot less problems on supply chain, because you have to handle only one component instead of 30, 40 that you would have if you go for a proprietary RF interface. All right, and also the cost. We go for every expensive component. So when you will buy our model, you will have all the expensive components inside it, right? Yeah, that was the point that Ferdinando pointed out. Our model, we assure, is the model that has the higher feature over power over area capabilities ratio. So if you want to have more GPIOs, you have to go for extremely big modules. If you want to go for little models, you will have to shrink the capabilities, so the GPIOs and all that comes with them. So that, we think, is the best trade-off regarding the model panorama, LoRaWAN model panorama. So let's come into details on how do you integrate the MAMWLE into any device. That's in some way the final question. We support you with documentation. We have a very, very detailed data sheet that I will show you now, because I want to point out some aspect. Here. Yeah, here I am. If you want to, all the documentation regarding this model is possible to be downloaded on our website. I will show you also that. That is our website. That is the section regarding the MAMWLE. Down here, you will get all the documentation regarding the schematics, data sheets of this model, libraries, and certifications. I will get back to it very soon. Let's see the data sheet at first. In the data sheet, you will find every information you need. It's a very, very rich data sheet. That's a nice thing. You have the complete pinout of the model, and also divided by serial communication. So if you want to use, for example, the UART, you go there and you look what pin do you need to implement. Also, the same thing for SPI. You get at the first glance the GPIOs that are connected to the serial peripheral that you need. Here you have all the characteristics and peripherals that are attached to every pin. For example, timers. For example, even here serial communication comparators. So analog comparators, ADCs, everything. One thing that I want to point out is this pins which have this apex. These pins are not available outside. What does it mean? Of course, these pins are internally connected. That's why that's because we integrated a lot of peripherals inside. One, of course, is the T6O that I explained earlier. A T6O, it's very, very stable, but consumes a lot of power. So what's the only way you have to consume less power having a T6O is turn it on only when you need it. So you turn it on only when you have to use the radio. So for transmission and reception of messages. And that is all handled automatically by software and by a GPIO. That is the VDD T6O, which supply the T6O implemented in the model. There are other 3 pins that serves as internal operations. That does the FE control. These pins are useful to select the TX power path of the model, and also the RX path. So with these control signals, you will control the of course the reception and transmission of messages. That is all handled by software, and later I will explain you how. You will find everything on the STM32WL examples, where I advise you to start, but I will get back to it later. And that's the data sheet. You have also a final section on how to program and debug the MAMWLExx, which is very useful if you are a beginner. So you have to follow these guidelines, and you will be good. I will return to the presentation. So as I said, we give you the data sheet where you can find a lot of informations. We give you the Altium resources regarding footprint and schematic symbols. That is not an easy way as well, because a lot of times you find footprint which are not tested, which are not reliable. You go on Snapida and you grab a footprint. You have to double and double check it to assure that that footprint is the right footprint. So you have to check the dimensions on the data sheet. So you would be better to do it by your own at you know. So we give you directly the footprint and the schematic symbol, which are fully tested. And as Ferdinando said, we have a lot of designs which use this footprint, and we didn't face any problem during assembly. Everything goes well during this footprint. So I really advise you to download it by our website and use it. Another tool that we support is KiCad, which is a very, very good tool as well. It's a more obvious tool, but it's getting very, very professional by year. So we deliver also the footprint also for this tool. We give you also the development board project on Altium, and the development board is this. That's the development board that we use to go through certifications. So I strongly recommend you to use it as a baseline, especially if you are a very beginner on hardware design, because using it as a baseline, you will 99% pass all the certification, and you will not have any problem regarding EMIs or EMC, as I said. So you can download it by our website. If you want, I think that you can also import it in KiCad. I think there is a tool that makes it possible. We didn't try it, but I think that is possible. So you have a lot of resources to work on, of course. We gave you also the dev board schematic, of course. With the dev board layout comes the dev board schematic. And that's a thing that I would like to explain better, because here you can find the only 2 or 3 tips that you have to follow to implement these model in your own design. So I will explain you better in doing this. Okay, so here are the schematic. As you can see, here is the symbol of the model. The key aspect and the things that you have to do are very, very simple, and are only the placement of these 3 decoupling capacitors near the VDD pins, so the supply pins. You will find when you use the model footprint that near every VDD pin, so every supply pin, you find a ground pin. That is to reduce the parasitic inductance, so to the supply of the model to be the most clean as possible. So you don't have to worry about it. There are a lot of decoupling capacitors just inside the model, but of course, 3 capacitor costs so less than. So I advise you to put them anyway. Another thing that there is the VRF pin, which is the voltage reference for the internal ADC. that pin can be used as an output reference. So there is the model that gives the voltage outside to be used as a reference for external circuits, or it can be used as an input. So as an input for the ADC. In that way, the voltage that you have to apply to this pin must be from 2 volts to the VDD, so 3.3 volts. You have to stick inside this parameter. So from 2 volts to 3.3, you can choose everything, for example, 2.5 volts or 3 volts, but you have to stay inside this limit. The reset pin, an important decoupling capacitor that you have to put, I strongly recommend to put, is the reset pin decoupling capacitor. And of course, if you want, you can put a switch to reset the pin by the outside. There is the boot 0 pin that every STM32 microcontroller is the pin that controls the boot mode of the microcontroller inside. If this pin is grounded at the startup of the MCU, the microcontroller will start executing the instruction, so the firmware that is contained inside. If this pin is pulled at the VDD, so 3.3 with this pull-up resistor, the microcontroller will not run the internal firmware, but it will expect to be flashed by a programmer outside. So it stays in the boot mode and it controls until an external programmer is connected and to be programmed by the outside. Of course, another very important thing, you have to choose when you implement this model if you want to go for the external antenna design or go with the internal antenna design. If you go for the external, as in this situation, you could choose to use the external filtering, which is done by this PI filtering. We give you the tested components that you can choose to filter the output and input of the RF part of the connector, or you can use this component to match to the external antenna if you are able to, of course. If you go for the coax, so the micro FL connector variant, this pin will be not connected. So this pin, of course, is not internally connected, and you can you have to not connect it, of course. Another thing that you have to do, of course, if you have any microcontroller in some way, you have to program it. So we put in this development board a Nestlin programmer, which is the one that comes out from the ST-Link V3 with this ribbon cable. So this is nothing more than a programmer which uses serial wire debugging communication. So with this connector, you will have the UART, so the serial COM port, to print all the things during debugging, during testing of your firmware. You will be able to log all the prints that stays in your firmware, and you will have also the serial debugging interface to of course, debug your microcontroller. If you use this serial communication, you will not have to control the boot 0 pin, even if the boot 0 pin is stuck to ground. So the microcontroller would be in a sort of outrun mode. The serial wire communication is able to reset the pin, the rest of the microcontroller by outside. So you don't have to control anything by yourself. You will do anything by the programming workspace. For example, STM32 IDE. All right. I'm quite done. That's the question. Another question: how to program the model. I just discussed it in some way. There are two ways to do that. One is the JTAG and SWD mode, which is the one that I explained to you. That is especially for debugging purposes. And another thing is using the UART and SP or SPI serial communication. But in that way, you will have to handle the boot 0 pin to make the microcontroller to enter bootloader mode. And that is the schematic picture about the connection of the development board to PC. That is very, very simple. You have to connect, of course, the ribbon connector, like it, and connect a USB, micro USB connector to the PC. The next thing that you will have to do is, I advise to you to go through the STM Cube IDE workspace. You can download it from the STM website, and you will have to download all the resources regarding the STM32WL microcontroller. What I advise to you is to start your project by using LoRaWAN and Node example, which is a good starting point for what regards the firmware programming of this model. We used, as I explained before, for basing on the datasheet, the internal connection that we did for the T6O supply and for the RF switch and internal connections, we wanted it complying with all the examples that stays in the STM32WL documentation. So you will be ready to execute every example that stay in these documentations, because we designed the model to be compliant with the STM32 Nucleo boards. So that is enough. Don't be worried if I went a bit, if I didn't explain everything about it, but I think that there will be another webinar regarding this argument. So regarding the programming of this model and all the things that comes later. So now I would like to pass the last consideration to Ferdinando.
Yeah.
I don't know. Yeah.
Yeah. So thanks, Gabri, for all the explanation. I think it was really, really interesting. And you know, we have some question that we were going to answer. Then
Yeah.
I think we are reached the times line. So FCC planning, which time frame we are already planning, and we are going through FCC right now. So we'll be out in a couple of weeks. Everything looks good, so no worry about that. Yeah, so we provide the layout references and design. As you could see, there is on the website. Of course, if there is any question about it, we would love to answer your question. And right, regarding the shortage period, we have a huge number of modules, and you know, we explain we shouldn't have any problem regarding the supplying of any modules.
Yeah.
How we supplying the module? We supplying by distributor. You will find it to the most known distributor, but just drop us an email and we will hook it up with distributor in your area, or you know, any other kind of distributor that you need. All right. So thank you very much for the times. And if you have any question, you can email us. And I hope it was a nice time spending. So thank you very much. I'm looking forward to meet you again. Bye-bye.
Bye. Bye, everyone.